So I'm going to talk a little bit about .NET 5 on the Raspberry Pi. I recognise some faces in the audience there, so I think some of you have at least spoken to me about this. If not, you've already been to a talk about this, so you'll see some of this before. But if I leave enough time at the end, there's a little cool demo that I'll give. So a little bit about me. So I'm an IoT developer, essentially. I run my own company. I've been doing that for a decade now in and around the IoT space. But I also co-organise .NET Knots, and I run Knots IoT and Knots Dev Workshop, and I'm part of the Agile Engineering podcast and a Twitch stream and about 1,000 other things, Pluralsight author, Azure MVP. So I like to keep myself very busy, which is great or not great. Depends on if you're my wife or not. But what we're going to talk about, a little tiny bit about .NET 5, and then how you go about installing that on a Pi. And then we'll do a couple of Hello Worlds. And then we'll talk about the Raspberry Pi GPIO, or general purpose input output, and a little circuit that I've got here. And then we'll do some basic GPIO control stuff, and then we'll talk about the device bindings libraries and what you can do, including driving servos for that. And then if there's any time, Q&A, which there probably won't be. So .NET 5 is now cross-platform, and you can pretty much target any platform you like, in fact, including the Pi, which is nice. But we also get some nice new language features like records and init-only properties that turn that sort of a structure into something a lot simpler. We also get pattern matching on types, which is nice. I quite like that feature. Top-level programs where, before we had not many lines, but now we can go just down to 2, which is great for people just starting out. So if you're coming from something like Python or something, it's quite nice to come across to a top-level program like that. We also get system.text.json, so that makes James Newton King a little bit sad that we're not using his JSON library anymore, but it's all right. They gave him a job. So installing .NET 5 on the Pi would normally be quite a complicated set of downloading binaries and linking and modifying your .bashrc file and things like that. But I've actually created a single line install for that now. And don't worry, I'll share the link to the slides once I've published them, so you don't need to worry about trying to scribble down that big long line there. But this will download and install the latest .NET 5 files, everything you need to be able to not only run but also build .NET applications on the Pi itself, and a couple of other little bits and bobs. It's quite quick on a Raspberry Pi 4. It'll only take a minute, maybe, depending on your internet speed, of course. And once it's done and you've rebooted, then you've got .NET 5 all up and running on the Pi. Once you've done that, then make sure that it works with the console app. So I have dialed into my Pi here using something called Putty. This is a terminal emulator. Just allows you to be able to SSH into the Pi and run commands on there. If I go too quick or gloss over something, then I don't mind. People just stick the hand up or wave at me. Then I'll try and help you out with what it is I'm doing there. But we can do a .NET new console, and we can stick that in an output of like console 1 because we're inventive there. And just make sure that can actually create us a console application. I'm running this on a Pi 4, so it's relatively fast. But, I mean, this is still not going to be as fast as running on your actual PC. This is demo environment. So I've got plenty of blog posts that show you how to do all the development on your PC and deploy to the Pi just to run and debug, which is definitely the way I'd recommend. But for demos like this, we don't need to go that far into detail, certainly not for a lightning talk. Once we've got the console application spun up, we can just make sure that works with .NET Run, and we should get a normal hello world. And again, I mean, it's not going to be mega fast. It's still only a Pi, but it's not too bad. And that sort of just shows you the speed differential between your nice fast PC and a Raspberry Pi 4. So back to the slides there for a second. If we talk about GPIO, so this is general purpose input output. So it's things like driving LEDs and reading buttons, but it goes further than that. So you've got serial interfaces and PWM pulse width modulation, and I2C and stuff like that. There's a library that you can use, a NuGet package, the system.device.gpio NuGet package, and you just pull that into your project, and then that gives you access to the GPIO on the Pi. Yes, JetBrains raffle. Let's not forget about that. It's very important. And once you've got that on there, then yeah, you can start driving LEDs and reading buttons and driving motors and things like that. That's your gateway. That's going to do most of the heavy lifting. It supports Linux and Windows 10 IoT. I don't recommend anybody uses Windows 10 IoT anymore. I think the last update was like October 2019 or something. And the fact that we've got things like .NET on the Pi, and if you wanted to do UI stuff, then there's a few different ways of you being able to do that. But Uno platform is a great way to be able to do that, and you can target the Pi for that. As I say, you can just install it from the CLI, or if you're in Visual Studio, use the package manager by all means. If you've never seen the GPIO on the Pi, then it looks a little bit like this, where we have a bunch of pins with numbers, and each of those pins has got a different function. So some of them will just be plain inputs or outputs, but some of them will have unique functions like the TX and RXD pins there for transmit and receive for a serial port, or PWM there, and there's some power pins as well. As far as numbering is concerned, we can see that there's numbers next to the pins there, 3, 4, 5, 6, 7, and 8 going down there. That's the board numbering scheme, and that's the scheme that I tend to use because I can count pins. I may need to recount, but the other scheme is this BCM numbering scheme, which refers to the chip that drives the I/O on the Pi, BCM chip. So they do surface that numbering scheme, and so through that device.gpio NuGet package, you can choose to use it if you like. But I just don't recommend you do, because then you're into converting between BCM 14 to pin 8, and you've got to get a list up somewhere, and you're just wasting your time. So just don't bother. I've got beside me a little circuit here made up of what is Hello World for IoT. So an LED that you flash and a button that you read. And if you're ever going to do any form of IoT, this is probably the first thing you want to do, is flash an LED and make sure you can read a button. And don't worry, you can even get that wrong if you get the LED the wrong way round, or those little micro switches. If you don't quite know where to plug things in, you can get that wrong as well. So even Hello World can go wrong, but once you've got the circuit working, it's great. You've done something then at that point. So I've got this wired up. So pin 10 is connected through a resistor. Now you need a resistor because an LED can draw something like 30, 40 milliamps or something like that, and that could just be more than your Pi pin really wants to sync. So always stick a resistor in there. 220 ohms is perfectly fine. And then over here on pin 26, I've got a button, and then both sides of that circuit are connected down to ground, so that you're making a circuit there. Interestingly, internally, what I've done, if you know anything about electronics and you didn't know about the Pi, that button there could just be seen to be floating. But inside the Pi, there's a pull-up resistor. So if you're not pressing that button, it's just going to be sitting there at a high level. And when you press it, it's going to connect that ground wire to that pin. So it's going to take it low. That's important later when we look at the code, because it's going to make things look a bit backwards. But that's just how this is wired up. So let's do Hello World again. Now, I'm not going to type all this code in, but I am going to show you what it looks like. So if I switch across to Visual Studio Code, here's some code I prepared earlier. So I'm just going to get rid of that off the side and zoom in a little bit so you can see a little bit better. So at the top here, you can see we're using that system.device.gpio. So obviously we make sure that we bring that in. I always leave Hello World in my applications, because if you are doing an application that just reads a button and doesn't do anything else, flashes an LED when you read a button, and then the LED only comes on when you press a button, but you press a button and nothing happens, you don't know if your application is actually running or your button's not wired up right. So I like to have that Hello World at the start, just so it's sense checking me. It's running now, and it can take a little while on the Pi. You saw Hello World can take a little while. Far more complicated programs might take longer to start. So it just gives you that. I mean, you don't have to say Hello World, obviously. That's where we're starting with this. Next down here, we've got our GPIO controller. So this is what is going to be allowing us to drive all the I/O on the Pi. And you can see here we're passing in that board numbering, that pin numbering scheme of board, which obviously you can pass in that BCM numbering scheme if you're crazy enough. Just don't do it. Next, we've just got a couple of variables here. We're defining the pin. And if you remember, we had our pin for the LED connected to pin 10 there. So that's what we've got here is that LED pin. And then we've got a light time. And this is what we're going to use this in a delay in between turning an LED on and back off again. Because if we don't have a delay, then it's just going to kind of flicker far too fast for any camera and even for your eye. So we have a delay in between there. Next, we have this open pin. So we use this controller that we defined above. And then we open a pin and we pass in our pin, which is 10, and we tell it that it's going to be an output. So we're going to drive the LED at this point. Next, we do what every good programmer should do and wrap all our code in a try-catch. And then we take our controller and we write to that pin a pin value of high. So that should turn the LED on. And then here's that delay that I mentioned earlier, 300 milliseconds. And then we write to the pin low. So all this is going to do is just, in this while loop, flash our LED on and off every 300 milliseconds or 600 milliseconds, depending on how you want to take that. And then we close the pin. We don't necessarily need to do this because exiting the program will close the pin for us. But I'll leave that in there just as a reminder that, if you're not going to be using a pin anymore, close it. If later on you need to be able to use it again later, then you'll be able to open the pin and you're not going to cause yourself any headache. So let's just see how that works, shall we? So if I just run this, and with the magic of OBS Ninja over here, I have a feed, flashing LED feed. So I've got one of these Okio cams, which are quite handy actually. So it's a top-down 4K camera. Don't need 4K for what I'm doing here, but it gives me this nice little way of being able to see it's live. It's not recording. But that's your epitome of Hello World 100 level IoT there. So once you've got that far, then you're rocking and rolling. But essentially, we really need to make sure that we can read that button in as well. So I am going to stop the code because if you don't, then it can cause you some problems. And then I'm going to switch branches and I'm going to go to my read button. And I'll scroll up and I'll just go through the code very quickly again. There's not much different. Still pulling in the GPIO. We're still doing Hello World. We're still creating the GPIO controller, but here we've got a button pin on 26. And if you remember, that's where we had our button connected on pin 26. Then we're still creating the output for the LED, but now we're opening the button pin as an input pull-up. And this is this pull-up resistor that I was mentioning earlier, just so that pin sits at a definite level to begin with, and then it goes to a definite level afterwards. It's something called an open collector pin. So it'll just float otherwise if you just do an input, and it might be all right or it might not. And you're just going to cause yourself some circuit problems. If you didn't have this, then you would just put a pull-up resistor directly on the circuit, but it just saves you having to add it. So down here, the code is quite similar, but I read that button pin, and if it's false, then I turn the LED on. So this is where it's backwards. Because we're pulling it up and it's sitting there when you're not pulling it, it's going to be high, it's going to be true, it's going to be a 1. When you press it, it's going to be false, it's going to be 0, low. So it feels a little bit backwards, but I always just have to point that out to people because you look at that code and you go, that's all backwards. What are you doing? You don't know what you're on about. So that's what that's there for. And then I was closing a pin. I'm not closing all the pins. That's just a reminder. So let's just run that and see how that works. Over here. The LED just happened to stay on when I finished. So we should see that go off. So that tells me that program is running. That's just look. And if I press the LED now, from an angle that doesn't obscure it, then we light the LED. That's probably the most expensive connection between a button and an LED that you'll see with a Raspberry Pi in the middle and an SD card and all the rest of the infrastructure that I've got hanging off that Raspberry Pi. But that tells you now that you're controlling outputs and reading inputs. And you're happy at that point. I always say you should be anyway. So that's that. So let's come out of Zoom and go back to our slides again. So you can go further than this, and you can do something with the rest of those pins with somebody else's code, which is always a great way to start, because the less code you've got to write, the better. Now you can control serial and PWM and that sort of stuff with that system.device.gpio NuGet package, but there's another package, this IoT.device.bindings package, and when you have a look at it, and there's you go on the GitHub page and you go to the devices list, and there's, I don't know, 40 different devices in this list. Everything from temperature humidity sensors to IO expanders and Explorer hat, the Sense hat. I don't know if anybody has done any stuff with the Pi, but Tim Peake took up these boxes, 2 Raspberry Pis, and they had a Sense hat, and it's got a gyroscope on there, and a magnetometer, and a temperature and humidity sensor, a little display. And he took 2 of these up there, and children can write science experiments that run on the space station. And it's going on at the moment. It's called AstroPi. Mission Zero is what it's called at the moment. It's a fantastic way to get kids and young adults into STEM subjects, is to tell them that you can write code that's going to run on the space station, and you'll get the results back and a certificate and a picture of it running. And it's just an amazing thing that the Raspberry Pi Foundation and the AstroPi team have done. And kudos to them for doing something like that. What it also allows you to do is drive servos. So a servo is a like a little mini motor, and it uses PWM, pulse width modulation, to be able to set its position. And the bigger the pulse, the further around that servo will go. And there's 2 different types of servos. There's 180-degree servos, and then there's 360-degree servos that are more like motors. Now, what I've got, if I switch across to my camera again and pull in this from over here, is, in fact, if I just give you a little bit more altitude, then I've got a robot arm that I've wired up here. How am I doing on time, by the way, Kev? Are you like militant? Are you going to chop me off?
Keep going, it's fine.
That's all right. So yeah, what I've got here, you can see that there's a servo on the top there. You need a top-down view of it, but these things are pretty simple to wire up. So I've got this board, this Servo 6 board down here. The wire's a little bit in the way. Now it's jiggling. But this allows me to be able to power the servos, which is just you can't connect servos directly to servo jitter. Yeah, exactly. Yeah, you can't connect servos directly to your Raspberry Pi. Well, you can, but you'll likely blow it up. Those things will take quite a lot of current, certainly on stall current, when they get a bit stuck. So this board has got a battery pack that I'll plug in now. You see, look, the arm moves all on its own then at that point. It's a little bit jiggly because I've not screwed it down at the bottom. But, you know, it's fine. So with control of those servo motors, then you can start making things like these robot arms. So if I switch across to my code again, and we go up a bit to here, then at this point I've got some servo code, if you will. So I brought in some extra bits and bobs here. I've got this system.device.pwm. So that's part of the system.device.gpio, that system.device library NuGet package. But here we've got the IoT.device.servo motor, and this is the device bindings NuGet package stuff. So PWM is great, but we just want to write an angle. We just want to tell it to go to 0 or 180 or somewhere in between. We don't want to have to start worrying about frequencies and pulse widths and stuff. That's just too complicated. So down here, we still need to create this PWM channel. And there's some stuff you pass in there, like the chip number and the channel number and the frequency. There's demo code for this, and you just copy and paste it, and it kind of just works. Next, you create yourself a servo motor, and you pass in that PWM channel, and then you tell it its angle, its greatest angle, 180 degrees for hours, and then the minimum and the maximum pulse widths, and these are just numbers that were in the demo code, and it just works. But if your servo motor doesn't go all the way to the extremities, these are the numbers you need to modify. And I've got 2 of these in here. because there are 2 hardware PWM channels on the Pi, and these are the best ones to use because the Pi handles that. You kind of tell it what to do, and the Pi just does it in the background. There's something called software PWM, and you can do that, and it does work, but it uses a lot of system resources because it's got to be really precise with those timings. Otherwise, servo jitter, as somebody put in the chat there. After I've created those 2, we start them up, and you know when that happens because it kind of engages, as Picard would say. And then down here, I'm just telling it to do a dance. So I've made it at the bottom, I've made this little move to angle, and it just takes a servo and an angle. And I'm just telling 2 of the servos to go between 2 sets of angles in a loop. So, I mean, that's kind of how that's working. And then I stop the motors afterwards. This one is important, actually, because if you don't stop those servo motors after this, like the LED was just left on earlier, it gets stuck. And you saw that I was able to actually move my servo, my robot arm there, because the servos aren't engaged. Once they are, I won't be able to move that, not without breaking it anyway. So that's just a little bit of information there. So if I go back here now to this, I probably should have stopped that, but I'm sure it'll be fine. He says, crossing his fingers. If I run that and then switch back over to here, all being well, let's move it in a bit further. It should start dancing. Oh, there we go. So that, I mean, there's not much code there to get a robot arm moving, but it gets cooler than that. And I don't know whether or not Kev's going to give me the time to show you the cool demo. Have I got 2 minutes?
Yeah, sure. But if people start dropping off, it's not my fault.
Yeah. Okay. Stick around for this. It's cool. Right. So I've stopped the code for that. What I've got here is I've created a Blazor website, and this is a feed from that camera. And these controls here, once I spin the code up, will allow you to remote control this robot arm. So if I switch across to the main branch, I'm not going to go through the code. It's in the GitHub repo, which I'll link to at the end. But if I run that up and get this back up again, you're not going to be able to see this very easily. In fact, if I zoom out a bit, then you might be able to see it possibly. There we go. Something like that might be a little bit better. Let's see if this is running. Yeah, it looks like it is. So let's try it. Oh no, tell you what I didn't do. Ugh. That's connected to my local machine. So I need to actually point it to this one. Apologies. Just here. Save that one. Let's run that again. The bigger version of this, I spin up a local Blazor website and show people how that gets built up. And that should now. There we go. It falls over as well if you're not careful. Oh, and that is actually moving. But you can absolutely go to that web address if you like. And there we go. I think that other servo there has been a little bit temperamental in the middle, but that one does actually work. It might be that I've got a piece of code that I need to change, but yeah, by all means, have a play if you want. In fact, I'll put the link. Oh, somebody's already gone there. Look, I'll put the link in the chat. There you go. And so it should only let one person control it at a time. It'll sort of give a please wait for the other people trying to do it. But yeah, it's quite funny watching this. And some of you might know Shahid, and he's emigrated to New Zealand, and he was controlling it from the other side of the world, quite literally, which was quite cool. So yeah, I like that. There you go. So yeah, and with that, I'll switch back to my slides and just sign off. So there's some links here. Again, I'm gonna share the slides, so don't need to worry too much about that. There's Knots OT if you like IoT stuff. Then on Thursday, that shouldn't be that slide. Actually, that's the wrong slide. But anyway, we have got a meetup next month. I think it's Thursday, the 18th of March, as it happens. So we've got Olivier Block coming along to that. And also, I'm making a set of courses on Pluralsight to help you pass the AZ220 developer exam. And you can contact me at loads of places, but at Pete_codes is a good place to get me on Twitter. And with that, that's me done. Thank you for listening.